Hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at a measure of central tendency referred to as the median. And this is going to assist us find some of the ways of evaluating this specific set of, or rather a kind of average from classified or grouped or ungrouped data. And in this case, I'm going to go through a various set of representations. But basically, I'm going to start with this specific set of data which I've given on my right side of the board. Now, from our introductory part, they defined basically the concept of a median as a value that is going to be dividing a data or a variable into two equal parts. And of course, we're going to see that this specific value is going to be obtained from a specific series of data which has been organized in terms of an ascending order, or from an ordered series of a specific set of data. And we are given a general case for our representation for the values of a particular set of data which can be organized in terms of x1, x2, x3 for a general variable of x up to xn. And we said that we can obtain the specific a concept of this particular average of the median by arranging this one in an ascending order, in a way that this specific value of x1 is going to be smaller than x2, which is smaller than x3, and this is going to be going on up to a range of values of the last one given as xn. And of course, from this one, then therefore we're going to obtain this one, of course, the median as the middle value of this specific series. And this is going to be denoted using this particular notation which are given, and this is going to, of course, imply the median. Now we're going to look at various procedures that we can use in order to obtain a median from a grouped or ungrouped data. And from our case, of course, as I said, I'm going to use this grouped kind of data on my right to represent one of the ways of finding this median. Now, as we can see, this constitutes of a class frequency and cumulative frequency of this specific data, and we're going to use it, of course, in trying to represent that. Now, for a continuous frequency distribution, the median is given in terms of this specific formula, which constitutes the lower class boundary of the median class given in terms of this specific representation. And that one is going to be added to the plus the size of the median plus divided by the frequency of the median plus given as that, and this is going to be multiplied with the total number of observations given in terms of n divided by 2, and then we shall have this one minus the cumulative frequency of the frequency of less than type preceding the median class, like the one that we have given on the, of course, right side of our board. So in summary form, of course, this is going to represent a way of representing the median. And I've said that this basically is going to be given using this particular notation that constitute the lower class boundary of the median class plus the class size of the median class divided by the frequency of the median class multiplied by the number of observations divided by 2, divided by or minus the cumulative frequency of the frequency preceding the median class. Now, in this case, if we are going to evaluate the median class, as we see, the median is going to be the middle of, or rather the middle value of this specific series, and we can represent this one by finding half the cumulative frequency given as such, and this is going to represent our median, of course, class in this particular case, or a frequency that's going to fall be representing the median class in this particular case, and this is going to be equivalent to 35. So that's going to give us a value of basically 37.5, and this is going to be equivalent to or greater than the cumulative frequency representing the median class in that particular case. So if you try to look at the cumulative frequency, then a value that is equivalent to or greater than that specific value for the median class is 39, and then therefore it's going to of course imply that median class is 54 to 50 or 50 to 54 given as such, and of course we shall do an evaluation then therefore in trying to find our median from that specific concept. So first of all, we are given a set of data that's constitute of a class and a frequency, we're going to evaluate the cumulative frequency less than type by adding these subsequent values in order to obtain the total cumulative frequency given as such. And that is going to assist us in finding the frequency that is equal to or greater than the frequency of the median class given as such. Now from there, we're going to obtain other specific values, whereby we're going to see that from this particular case, we have identified the class, which is 50 to 54 given as such. So therefore, for us to obtain the lower class boundary of the median class, we're going to see that this is going to be a lower class limit of the median class minus the units of measurement divided by 2. So this is going to imply the units of measurement is the difference between the upper class boundary of the preceding class and the lower class boundary of the median class. And this is going to be 50 minus 1 all over 2. So this is going to be 50 minus 49 is equivalent to 1.5 given as such. So therefore, our value for this one of our represented as 49.5, and we shall have a class width as the difference between this specific value. So we shall have it as a range between R over K, where R is the range over the number of classes, and the rest is the difference between 74 minus 40, which is the upper class boundary of the last class and the lower class boundary of the first class. And then we shall have this one divided by the number of classes, which are 1, 2, 3, 4, 5, 6, 7. So this is going to be basically 34 divided by 7, which is basically going to give us 4.85, an approximate value of that. And as we said, we're going to do a roundup to this specific figure for us to obtain a whole number, which is going to be a value of 5. So basically, we shall have our W represented as 5. And then we're going to identify the, of course, the frequency of this specific median class given as FMD, which is 22. And then for the value of N, as we said, this is going to be equivalent to the total frequency, which is given in terms of 75. And we shall have this particular value of C given as the frequency of the class preceding the median class given as 17. And of course, we shall going to obtain. So these are the specific values which we're going to be using in trying to evaluate our, of course, median from this grouped set of data. So we are going to do a direct substitution for this and find the median represented in terms of this lower class boundary is going to be 49.5 plus the class size is going to be 5 divided by the frequency of the median class. This is going to be 22 times n over 2. Basically, we have said that this is going to be 75 divided by 2 minus 17, which is the cumulative frequency of the frequency preceding the median class. So we are going to find this one as a value of 54.16, and that's going to form our median from this set of grouped data which I've listed. So in our next video, we're going to look at a way of finding the median for ungroup data, and that's going to form a comprehensive part of the concept of this particular set of average that we refer to as the median. So kindly check our description boxes for various links of other videos which are going to be, of course, under the topic of statistics, and they're going to form a comprehensive part of assisting us understand this broader topic. So that is it for now, guys. Bye, God bless you. Catch us in our next video.